Hi everyone. Welcome to NASA Space's Toronto virtual session. So I am Sayuran and I'm your local lead. So I think we have Sean here, Sean Mitra, who is a professional member of North American Space Institute and the co-founder and CEO of Foundation Space Resources. So today, Sean will explore how open lunar data sharing enables commercial lunar missions. So I will give Sean to talk about it. And thank you, Sean, for joining the session.
No problem. Hello, everyone. Good to see you virtually, though I imagine for good reason everyone's cameras are off, which makes sense to me. Hi, everyone. My name is Sean Mitra. I am co-founder and CEO of Foundation Space Resources. And by day, I am also a lawyer. So I've also got a lot of deep experience in working with both uh, regular legal issues, but also lunar legal issues around open data and what are the commercial and legal framework we might need to enable some of those use cases. So I'm here to talk today a little bit about both what's going on the moon more broadly, what are some of the equivalents on Earth, and also what we are doing specifically at Foundation Space Resources. Before I go any further, I should just double check. How's my audio? Am I coming through okay? Any issues?
Yeah, it's good.
Great. Okay. So, current state of situation of things on the moon are, as you might imagine, a little bit more, let's call it basic or nascent relative to the situation on Earth. And by that I mean we have a situation where most of the data currently available for imaging of the lunar surface is maintained by the various space agencies for open access to the public. So for NASA, that's through what's called the Planetary Data System, or PDS. And so that through PDS, you can get through to the geoscience data sets and imaging data sets of not just the moon, but also Mars, asteroids, and anything else NASA's collected. By policy, they maintain all of that up there. And I think you're already seeing our company is a great example how that open access has enabled the growth of interesting commercial applications and more specific and let's say specially tailored use cases for what that might mean. So let's see, do I have screen sharing? I do. So just one screen, but this is an example of one of the outputs that we've been able to produce from some of the NASA data sets. So um, what you're looking at here is a shot of the south pole of the moon. And as you can see, this is sort of the maximum percentage of illumination, and really more importantly, and why we framed it as solar power is what percent of time are you going to be getting percent solar availability for a solar panel at a given spot on the moon. And so you can see at the South Pole, there's very limited areas where you can get 100% solar power, but a good amount if you are open to 60% or less solar power, a good amount of other area. And so this is a secondary application that's proprietary based on the NASA provided imaging of the lunar surface. So we've gone ahead and simulated the lunar lighting conditions throughout the year, and then provided this percentage of time of when you'll get these lunar solar power availabilities. And so that's an example of the ecosystem that's being generated by these conditions. More broadly, you're seeing similar applications being done for mission planning. There's been a number of commercial lunar missions to the lunar surface. Most recently, Firefly successfully landed for the first time by a commercial actor, and we also saw successful landings by the Indian space agency ISRO, and JAXA, which is the Japanese space agency, had a successful landing with their SLIM mission. All of that with a broadly shared, based on and you leveraging the shared global lunar ecosystem of data that we have of the lunar surface, and understanding, okay, how do we take those relatively low resolution pieces of lunar image, low resolution images of lunar surface, and turn that into operational good lunar operations and mission plans that can achieve success. To contrast this a bit with Earth, we are now in a situation where there are still baseline data sets published by all the space agencies, but there are companies like Planet, Maxar, and others that have, of course, had much, much higher resolution data of the surface of the Earth that has been turned to commercial solutions like Google Maps, and then even more commercial options like which are sold for military applications to the U.S. military and the Ukrainian military, as well as for commercial interest solutions such as a company like GHGSat in Canada, which is taking from their own Earth observation satellites greenhouse gas emissions and selling that to governments and companies to understand where leaks are happening and where different gas emissions are happening. So what I think is really interesting about the lunar situation then is how do we go from a situation where there are really interesting commercial solutions enabled by currently available publicly funded and publicly made available for free lunar data sets, and how do we go from there to a broader, more vibrant ecosystem of lunar let's call them lunar apps and lunar mission planning. And I think that what remains to be seen is sort of a baseline for what we all need to survive on the lunar surface and to get operationalized on the lunar surface. And how do we get there? And then once we've reached that point, I think you then have second order commercially funded missions, which are then going to be providing higher fidelity, higher specificity, and more bespoke solutions in terms of satellites funded by commercial operators, and also, of course, companies like ours that are producing data products that are built off of those commercially or publicly funded and publicly made available solutions. All of that to say that, especially in a frontier environment like the moon, I think we're going to be relying heavily on public funding. And so because we're going to be relying heavily on public funding, that means we are going to have to continue to understand and operate in a world where data being collected from these missions are made available free to all the different players in the environment, to the environment for everyone within, I guess, global use, or perhaps, depending on the sensitivity of the mission data, within certain security protocols, but still made commercially available to all approved actors within the space. Some interesting questions then become, okay, if we have a completely commercially run mission, but it is completely publicly funded, so for instance, all of the missions are run that way, what are the guardrails for private data there? And what kinds of things are they allowed to sell and keep internal versus being forced to share publicly on PDFs and other platforms? Currently, the approach has been they have to share pretty much everything on a fairly quick time horizon. They're able to keep most of their data sensitive in terms of their findings for a couple of months, and then they're having to share it. But that's still being decided on a sort of mission by mission basis. And there's definitely flexibility there for anything that's deemed to be commercially sensitive or commercially proprietary. But I think we're going to see more and more of those guide rails formalized, and hopefully in international basis through international bodies like the United Nations Committee for the Peaceful Uses of Outer Space. That's a mouthful. People usually call it COPUOS. And we are also going to see really interesting things like data sets that are generated like ours that are synthetic or second order data sets that we are then selling back to the public space agencies as well as to other commercial lunar operators to then understand, okay, we've generated these different data sets and these findings. How do we then use those to then improve our operations, improve our situation, and improve publicly funded missions going forward into the future? And so you do have to make a sort of what's the word that I want here? You do have to accept that certain amounts of commercialization are necessary to make some of these companies viable. I feel like this is an appropriate point to say that if anyone has any questions, also Akshay, your mic's on if you don't mind muting. But otherwise, I'm happy to pause for questions at any moment in my presentation. I'm currently speaking into a black screen, which is always a bit awkward. I'll pause there if anyone has any questions while I think about where else I think things might be going in terms of lunar data. Hearing none, I think one of the most interesting aspects will be as we get to seeing geopolitical competition between the Chinese and the Americans, if there'll be any sort of formalized security requirements put on data and data sharing. Because as of right now, there tends to be a broad basis for sharing, and I hope that continues. But there is quite a bit of competition in terms of rhetoric. Both the Chinese and the Americans have said they're going to be there first. Never mind that there are a lot of countries and companies that are trying to work with both sides. And most notably, the United Arab Emirates and ESA both have planned cooperation with the Chinese and the Artemis mission plans. All the same, with some of that competition, you might see lunar data getting classified as some sort of national security requirement, which would then potentially limit what gets shared publicly on a platform like PDS, which is currently available for download. The other piece I'm really interested to see, and I'm hopeful that our company might be able to engage with, is also better distribution of the data. Currently, PDS is a system designed for, let's call it, preservation rather than sharing. So, which is to say that you can get everything going back all the way to the Apollo missions, so 1970s, which I think is really phenomenal. But at the same time, to find the data you need for generating like a map like I showed, you need to know what location you want. You need to know what missions went there. You need to know what dates they went there. You need to know what instruments on those missions went there. So, for instance, for the Lunar Reconnaissance Orbiter, there's a specific camera called LROC, or the Lunar Reconnaissance Orbiter camera. And so you'd have to know you want that camera plus the specific spectrum that you're looking at or the dates that you're looking at, and then also have to collect manually from different nested folders all those data sets and then download them and then manually or set up your own automated system to then consolidate all that data and put it together into a specific image. Um, so I'm hopeful that there will be some sort of unified unified system or updated system for distributing some of this data that is hopefully search engine searchable and also much easier to access, because without a better system for sharing that data, you have to run into problems where people don't even know what duplicative data might be starting to be generated over time. A second piece that I didn't touch on that I think also kind of falls into the realm of geopolitical interest and geopolitical tension is the tension between, let's call it commercial and geopolitical selfishness, i.e., the idea that you want to maintain your own operations, your own base, and the need for cooperation for safety and survival. Because the moon is a really harsh environment, it's really hard to get to. And so I think we're going to also see, hopefully, a push at the United Nations for pretty high, pretty stringent minimum information sharing about your missions. And so that goes beyond just imaging data from both rovers and from satellites, but also, planned operations, where you're going to land, what you're going to share about your operations. Probably you're going to operate in X radius around your landing site. Hopefully, you're going to share some information about where your rover astronauts or other operations are going to be based if they're mobile, and also what hazards are associated with that. So, for instance, if you have for a mining situation, um, any mining activity that isn't contained is going to kick up a lot of dust and a lot of debris. That debris and dust could interfere with communications. It could interfere with um, your actual landing and survival. Lunar dust is very sharp, and if you kicked up any larger pieces of material, that could be actually very dangerous. Or on the flip side, if you're building a base near landing pad, the material being kicked up could be really like bullet deadly and blast through a habitat set up nearby. So that means we're going to have to share some pretty high level data, which then again feeds back into, well, there could be a really interesting opportunity for, from this data sets being shared, is there the ability to build second order commercial products for relatively low cost to then assist with the furtherance of lunar operations? Or are we going to see governments put, let's say, licensing guardrails on these things and say, no, you can't build commercial solutions on these. This information is only shared for safety purposes and for non-interference purposes. And you'll have to go and then get further licensing agreements, which then gets to complicating intellectual property terms for people like me that are going to have to negotiate, okay, well, depending on what those terms are, how do we share these in an efficient way? And surely there could be benefit to everyone involved if you could think of some clever, commercially viable, and also uh, important risk reduction results from these potential apps that could be spun off of this safety shared data. I think would be really interesting. So there's again a tension there between furthering the larger lunar project and the communal goal of building a viable commercial lunar economy and a permanent human presence on the moon versus selfish commercial and country interest of trying to make sure they're the ones who are on top or succeeding there. Um, I think that optimistically, I think that some we will see a lot more of that information being openly shared and repurposed, made available for commercial efforts because the moon is such a harsh environment. I think all of the actors right now acknowledge and understand that sharing that data and sharing that information is to everyone's benefit and allowing for the flourishing of a secondary commercial marketplace, let's call it, of apps and companies that are building support services, whether physical or digital, I think will hopefully be of interest to everyone involved because it's going to be a monumentally difficult and expensive task to build a sustainable and functioning lunar economy. I think the last piece that I haven't really talked about, and I think this will take me maybe to about half an hour, and then I'll leave it to questions, and if there are none, we can just call it there. Is the fact that the end goal, as stated by both the Chinese missions and the Artemis countries, so that's effectively the Americans plus friends, but I believe the Artemis Accords are now about 50 signatories, so it's a bit more than, significantly more than the Chinese missions, which I believe have maybe 12 participants or supporters signed on to them. But both sides have said they want to build a commercial lunar economy. And so practically what that means, I think, is sort of twofold. One, you have an anchor customer of whatever governments are funding the permanent human presence of a base on the moon. So all of the support services around there are going to be part of that lunar economy, whether they're, again, digital or physical. But then secondarily, once a supply chain has been built from that base back to Earth, you'll have the really interesting piece of economic activities either unique to the moon or made feasible by the moon. And so that includes things like you'll see discussion if you Google commercial lunar economy, probably on helium-3. I'm personally skeptical on the economic viability of helium-3 for a number of reasons, but the purported mechanism there is that you will be able to use helium-3 for both building quantum computers and for powering nuclear fusion power reactors. And so even if there's a small quantities mined on the moon, that will be such a lucrative amount, it will be viable to ship back to Earth. Another thing that I think is more viable, the problems I see with helium-3 include the fact that we don't actually have that market there today. We don't have functioning fusion reactors on a commercial basis. And we also don't know how the heck we're going to get stuff back to Earth and what the cost of that's going to be. Never mind setting up the operation that is going to extract the helium-3 economically and also in a way that is sustainable for operations for the rest of the ecosystem on the moon. The other pieces of interest for mining on the moon, which my company's obviously named Space Resources, we've been conducting an effort into looking into, are both mining water. We have good evidence for water in what are called permanently shadowed regions on the South Pole. So those are craters where light never gets into. And so over billions of years, the hypothesis is that there are significant deposits of ice and ice fragments mixed into dirt in those regions. But we haven't done any physical prospecting yet, so it's never been confirmed. So assuming those are accessible, significant deposits of water on the moon, you can turn water into both hydrogen and oxygen. So you have supply of oxygen for breathing, once cleaned, water for drinking, and then hydrogen and oxygen are core components of rocket fuel. So you could then turn that into an operation where you're then selling water mined rocket fuel made from water mined on the moon for missions further out into the solar system, as well as for refueling satellites around Earth. This is particularly interesting because the moon's gravity is 1/6 Earth's. And so you have an interesting scenario where even if it is really expensive and really time consuming to set up that operation and get it going. Once you have a viable operation going, it is still much cheaper to launch off of Earth, off of the moon than it is off of Earth, and then refuel those satellites or go further or refuel from Earth and go further. Currently, any rocket leaving Earth has approximately 90% of its carrying capacity in fuel just to get out of Earth's gravity well. If you can cut that by 5, 6, let's say, that's a lot of room for interesting wiggle room in other activities. For the more fun sci-fi stuff, the moon's regolith or soil is very, very iron heavy. So if you can get into some sort of 3D printing environment or extraction environment, that's a ready supply of iron for building metal structures either on the moon, or if you can get it off of the moon into space for in-orbit manufacturing. Without gravity, you can get really wild designs and really massive designs that aren't going to collapse on themselves as you're 3D printing them, unlike on Earth, where of course gravity is a significant factor in limiting what you can 3D print before it collapses under its own weight. And then there's also the really interesting bits of, well, what does it look like to do things like 3D print organs or design bespoke proteins or crystalline structures in a 0G or low G environment, and what other possibilities are unlocked there. So once the ecosystem, the supply chain from the moon to the Earth, or even from, let's say, Earth orbit to the moon, gets matured over time, I think you'll start seeing really interesting and really economically valuable potential off on the lunar surface and enabled by human presence on the moon. But that's, of course, a longer term goal that I would estimate is 15 to 20 years out after we've really had a government funded push to enable these operations. There's also a lot of really interesting science to be done on the moon. So we still don't really know exactly how the moon was formed, but as well, the far side of the moon, so the side that is not facing Earth, is always facing away from Earth. And so that enables this really unique environment where there's no atmosphere and also no radio interference. So you could build some really powerful radio telescopes that are not enabled anywhere on Earth or elsewhere in the solar system that could get really big and then get some really interesting and high resolution views of planets outside of the solar system and detection of potential radio signals outside of our solar system. So there's also, for the search for potential habitable world or alien life, really interesting ramifications for science enabled by being present on the moon and having a more let's call it robust infrastructure environment to build something like that on the far side of the moon. I will stop there and open it for questions. I think that this is a bit rambly, but the thing that I'd stress is that open data enables a lot of really interesting innovation, and there's a lot of space data and Earth observation data, as well as lunar and Martian openly shared data that can be enabled for really interesting companies like ours. And I'll pause there. Thanks.
Thank you so much, Sean, for the great talk on open data and the moon. So I think if you have any questions, the participants, you can ask Sean. We'll give a few minutes, and if not, maybe we can ask offline as well. Like I will share an email, right? If it is okay, I can share the email as well. Yeah.
Sure. I see one question in chat. Oyce in London asks, when you're looking for places and problems where you and the team could potentially add to or solve, how do you go about finding these? Ooh, I mean, like I said, PDS is currently not the greatest system. I would go about searching individual government. I'd still use, okay, one, I have a lot of skepticism about the ability of AI tools like ChatGPT to do higher order tasks, but for a search like this, they're getting pretty good at searching things in response to a question. So I'd phrase something like searching government sites, including the Canadian government, the American government, ESA, and JAXA, provide me with data sets about this topic and what are publicly available. You could also just try mixing that with your own Google searches, searching for terms like JAXA plus Earth observation data. Canada, Government of Canada plus Earth observation data, or Canadian Space Agency or CSA plus Earth observation data. Try and link those terms together rather than just broadly what data sets are available. I think I would make sure to search for space agencies and governments and see if there are other specific terms that you might come up in terms of those space agencies and governments to see if they each have different things listed publicly. Most of them are interested in having their data used for economically beneficial, let's call it, purposes. So they have pretty good websites for searches. I believe the Canadian government, for instance, has a searchable database on their website for high resolution Arctic images, but I have not searched that myself in recent years. I think it's been a year or two since I last searched. As for problems, I guess the second part of that question, I didn't answer problems to solve. Problem to solve, I mean, that's just you just have to be creative and or take the time to learn about a specific industry. So for the Space Apps Challenge, I think that there's absolutely nothing wrong with identifying a problem from a quick Google and just trying to solve it. I mean, the purpose of the challenge is to demonstrate your ability to tackle a problem. Doesn't matter if it's been solved by somebody in a distant corner of the internet. If you haven't found it, that's fine. Like you can solve a problem. It's really about showing what you can do within the time of the Space Apps Challenge. More broadly, if you're actually trying to build a company, yeah, there's no solution. There's no replacement for just spending your time doing your due diligence and doing research plus talking to people. I think going to conferences, finding experts, asking them questions about the problem you're interested in solving, that's the only way to really learn if it's economically viable or if it's already solved or if it's chasing the wrong tree. And that's a problem a lot of startups, even outside of space and observation data, often make, is that they often make the fallacy of, I'm sure this is a problem, I'm going to solve it, without actually doing the market research to understand if this is a problem or if it is, what other people have tried to do to solve it before and why your solution may or may not work. All right, you
Do
can
we
give
have
it
any
a
more
minute
questions?
or two, but if not,
Yeah.
yeah.
I think we can wrap up. I think thank you so much again for the great session. This is the very first session we are having for the Toronto NASA Spaces. So I think only 20 people joined. So maybe later on we'll have more participants in the other sessions. So thank you so much again, Sean, and thank you so much everyone for joining. And we'll see you again. Yeah. Thank you. Have a good night, guys.
Great.
So,
Best of
thank you.
luck to everyone in trying out the challenge, and thanks for having me. Cheers.